Hello and welcome to Sourav sir's classes. Today we are discussing the ISI B-Stat paper, and this is the second subjective question that came in the paper, where we are given that f of 0 is not equal to 0 and f of 1 is equal to 0, and there are two other conditions given, and from there we have to find the solution, a recursive solution for fx, so that we are able to find all the values of fx. So first we substitute x equal to 1 and y equal to 0 in the first equation, which gives us f of 0 is equal to f of 1 plus f of 0 minus f of 1 into f of 0. So f0 cancels out from both sides and we get f of 1 times f of 0 minus 1 equals 0. So we are given that f of 1 is equal to 0, so this is 0, and that means f of 0 is equal to 1. Next we substitute the value of x equal to 2 and y equal to 0, so that we get x equal to 2, y equal to 0, and that will give us f of 0 equals f of 2 plus f of 0 minus f of 2 into f of 0 from the first equation. So we cancel this out and we get f of 2 times f of 0 minus 1 equals 0. So that means f of 0 minus 1 equal to 0, which means this is equal to 0. And then in the second equation we get f of 2 into f of 2 into f of 0 equals f of 0 into f of 2 into f of 0. So we transpose everything to one side, we get f of 2 minus f of 0 times f of 2 into f of 0 equals 0. So that means we know that f of 0 is equal to 1. So therefore f of 2 minus f of 0 becomes equal to 0. So which means f of 2 becomes equal to f of 0, which is equal to 1. So that gives us the value of f of 2. Next we will substitute x equal to 3 and y equal to 2. So x equal to 3, y equal to 2 will give us, from the first equation we will get from the first equation we will get f of 6 equals f of 3 plus f of 2 minus f of 3 into f of 2, and from the second equation we will get f of 1 into f of 3 into f of 2 equals f of 0 into f of 3 into f of 2. So from there we'll get f of 1 minus f of 0 into f of 3 into f of 2 equals 0. So which means f of 1 minus f of 0 is not equal to 0 because f1 is not equal to f0. f2 is equal to 1. So this is equal to 1, this is equal to 1. Therefore, f3 has to be equal to 0. So which means f3 is equal to 0. So now if I go on adding this, so from here I can get the value of f6 as well. f6 would be equal to f of 3, which is 0, plus f of 2, which is 1, minus f of 3, which is 0, into 1. So f of 6 is equal to 1. Now we are left with f of 4 and f of 5 to ascertain the pattern of the series. So we put x equal to 2 and y equal to 2 in both the equations. So we get f of 4 equals f of 2 plus f of 2 minus f of 2 into f of 2. Now we know that f of 2 is equal to 1. So this becomes 1 plus 1 minus 1, which is 1. So f of 4 becomes equal to 1. Now we are left with f of 5. So for that we put x equal to 5 and y equal to 4 in the second equation. So we'll get f of 1, 5 minus 4 is 1, into f of 5 into f of 4 equals f of 0 into f of 5 into f of 4, which means f of 1 minus f of 0 into f of 5 into f of 4 equals 0. Now we know f of 4 is 1 and this is 1. So f of 5 has to be 0. So f of 5 has to be 0. So now if I write all the terms in a series, so we have f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, f of 6, and so on. So it starts with 1 and then 0, then 1, 0, then 1, 0, 1. So the series continues like this. So that means f of any even term will be equal to 1 and f of any odd number will be equal to 0. So this would be the form of the series, and so the explicit form of the series would be will be 1 0 1 0, etc. So this is the answer to the part A, and answer to part B is where it is asking for us to prove that for fa not equal to 0 there will be infinite number of such elements. So we can see that the series continues in this form 1 0 1 0. So that means f of odd is equal to 0 and f of even is equal to 1. So there are infinite number of even numbers of the form 2n, where if I write x equal to 2n, where n is an element of natural numbers, then f of 2n will be equal to 1, and this would be an infinite sequence.